Today I wanted to give a little bit of a deeper analysis of the board and answer some questions for those of you that were curious about some of the details on it. So let's dig into it. First of all, the board was designed primarily for running in the snow, and it was more of a design challenge to see how a vehicle like this could do in snow, not necessarily in powder, but hard packed snow. You can see the ground clearance there. So being that the board was designed primarily for the snow, I knew I needed ATV tires, and I was unsure of how well a vehicle like this would lean steer, being as large as it is and heavy. So initially I had purchased some full-size ATV tires, and then I realized that it might be too big and heavy to lean steer properly. So I went ahead and got these small kids ATV tires. They're just cheap Chinese tires. I was unsure if these were going to work well, so before I get quality tires I wanted to go with relatively inexpensive ones. They're 13 inches high, in case you're wondering. So now we'll start with the deck and work our way out toward the axles. Inside the deck is a 6S 40 amp hour battery pack. Let me walk over here and grab one of these packs to show you. I am using two of these particular packs. These are Hobby King Multi-Star 6S 20 amp hour packs. I've got two of these wired in parallel in the box there. So that's what we're using as far as battery. Put that back over there. Alright, and so the pack is in the middle of the board. You can see the little hump underneath there. Quite a bit of ground clearance, but you can see the lump. That's to provide clearance for the battery pack inside the deck. And so there is inside this, under this cover, as well as the rear cover, is a Castle Creations Mamba XL controller. And I can get into the program settings at another time, but they're designed for large scale, fifth scale RC cars. They work very well, and in my main video I show what it looks like underneath this cover, but I specifically wanted to get into answering some questions. So as we move away from the deck, you'll see I'm using an air shock and a leading double wishbone suspension at the front, trailing double wishbone suspension at the rear. Now initially I was going to build the board at first without any suspension at all, but I knew that I wanted it to be very adjustable. I wanted the steering kingpin angle to be angle adjustable, and I wanted ride height adjustability. So I was already going to have to make some type of an adjustable linkage, and it was only one small step beyond that to actually add suspension. The suspension does work quite well, but one thing about it is that the suspension primarily works when both wheels are hitting a major obstacle at the same time. So for instance, going up or down a curb, and yes, it does run up curbs very well. I've done it several times without a problem. But if you're going up a curb or down a curb and both wheels hit at the same time, the suspension really works well. Now, if you hit a bump with one wheel, being that it's a lean steer vehicle, you have axle articulation, and so that axle articulation means that, let's say you hit a 4-inch bump with one wheel, this front suspension is only going to move 2 inches, because 4 inches divided in half is 2 inches of movement. The deck is going to move a little bit, so you're going to end up with maybe 1 inch of suspension travel at the suspension for a 4-inch bump hit of the wheel. So honestly, the suspension doesn't do as much as you might think until you start going through some very large ruts over large rocks, but mainly when the entire board goes up and down, sharp dips, you can look down and see the suspension moving quite a bit. But over uneven bumps, the axle articulation does more than the suspension. So that's an answer there to a couple of questions I had about why do I have suspension and why is it the way it is. A few people had asked about putting double wishbone suspension rather than this straight axle articulating skateboard type arrangement. I did indeed consider doing that. However, when I was building the board, I didn't want to introduce too much new technology into the equation, and adding double wishbone suspension would have been a very big deal. For one thing, it's already pretty busy up here. You can see the drive unit, the suspension coming from the deck. Double wishbone suspension would have been very complex, running from the center outward. It would have been probably, I'd say, 3 to maybe 5 times more complicated than this straight axle assembly, and I really didn't want to do that. I've already had a number of people mention that the board is way too complicated, and I wasn't too worried about complexity necessarily, but I only wanted to add complexity that was necessary for the performance I was looking for. So that answers that question. Let's see, the steering kingpin angle, what I finally settled on was anywhere from 40 to 45 degrees at the front. 50 degrees works as well, but 40 or 45 degrees gives me the sharp steering I'm looking for. At the rear, walk around here, the rear kingpin angle is on a quite a shallow angle. It is at 20 degrees, and that seems to help eliminate some of the weave that you get at high speed. There is still a little bit of weave, and that's because I've got it set up to steer sharply. So, but it's or to steer light, I should say. So I end up with a little bit of weave, but not a whole lot. Let's see some other questions. Oh, the question was asked why I have a belt and to a chain drive. Well, part of this board, let me walk around to the other side here. Part of the technology of this board is based on drive systems that I make for bicycles. So I'll show you here. This is what I call the Vinci Drive, and this is a drive unit that I've been manufacturing for bicycles. I've been manufacturing it for a number of years, and this is one of the most high-end electric bicycle drive systems on the market today, and I already manufacture belts, pulleys, motor pulleys. Normally there's a torque limiter here. This one has a solid hub. It's also got a 7/8 shaft. This is a little bit higher end unit, but anyway, I already manufacture a bunch of billet aluminum parts for bicycle drive systems. So you can see the similarities here. This is the bicycle drive system is a little bit bigger than what's on the board. What I'm using on the board is these are original bicycle drive systems that I started making years ago, and I had a bunch of leftover parts. So you can see from the front here, the motor is mounted to a flat plate that clamps to a round tube. That round tube has bearings in it to support the jack shaft, and you can loosen some pinch bolts, and you can actually clock the motor around that jack shaft bearing tube. Well, these were bicycle drive systems that I already had left over, the torque limiters and that, just inventory from my bicycle drive systems that I've been building in years gone by. So I already had these drive systems. In fact, I had just enough parts to make 2 complete drive systems. So that dictated that I couldn't put a drive unit at each of the 4 wheels. That was a question that was asked because I only had enough parts for 2. Also, these motors are crazy expensive. Could I have gone with less costly motors? Yes, but I already had the drive units for these motors in stock. These motors are $500 a piece, so 2 was all I wanted to put on the board. They're also ridiculously powerful. This thing is so overpowered. These motors look small, but they put out a peak of about 8,000 watts each under hard acceleration, and it's more than the board needs. But being that there's only one drive system for the front, one for the rear, that meant that I had, in order to make it four-wheel drive, I had to have a connecting axle from between both wheels, and that necessitated a differential. Let's see a better view of the differential under here. That differential it's I believe a Peerless brand, just a basic garden tractor differential. Initially I had it assembled with no differentials and you couldn't steer it. I didn't have the electric drive on it, I was just coasting, but you couldn't steer at all. So I knew I needed differential action, but I only had parts for 2 drive systems. I didn't want to spend $1,000 on 2 more motors and $500 on 2 more controllers. So also adding the differentials was less weight than adding more drive systems, less complexity. It was a lot of fabrication to add the differentials, but a few people have asked about limited slip differentials, or about, instead of a differential, what about a Sprague clutch at each wheel, allowing differential wheel rotation. It's something I considered, but here's something that you may not realize. When you're leaning, so let's say you're leaning, taking a right-hand turn, the inside rear wheel, taking right-hand turn, the right rear wheel is now turning slower than the outside wheel. So if you apply throttle, that inside wheel is going to want to drive inward, and it's going to jack the steering inward. It's going to make you oversteer and throw you off the board if you have Sprague clutches at the wheels. Also, with solid axles, the same thing occurred. You tried to steer, and once you started steering, the rear oversteered and jacked the inner wheel in toward the deck and would throw you off. So it was unrideable. So again, Sprague clutches don't work, solid axles don't work. Also, a problem with Sprague clutches is braking. Now you can't have electric motor braking, because if you try, it'll just freewheel on the Sprague clutches at the wheels. Now, as far as a limited slip differential, that would give you the same problem, is throttling while cornering would give you, the board would not corner, it would corner differently under power versus coasting. So limited slip, plus there are no small limited slip differentials out there that I know of, but you definitely want an open differential for this. Also, limited slip differentials are primarily for vehicles that are set up where you're going to have one or the other wheel unloaded at some point. But on a lean steer vehicle, you have massive axle articulation, so you have pretty much equal weight on all 4 wheels at all times. So open differentials, trust me on this, I looked at it 6 ways from Sunday, and open differentials are definitely the way to go on this. Let's see here, steering dampeners, are they necessary? I don't know that they're necessary to make a board like this function, but they sure do help. And one nice thing about them is you can reach down and click them just while being on the board and change the steering dynamic. If you want sharper, faster cornering, you would soften them. If you want more stability at high speeds, you could stiffen them a little bit, and just it makes a tremendous difference. So someone had brought up the differential housings and the ground clearance there limited underneath that corner. Let me grab a ruler here, and we'll measure that for you. So I admit that's a concern. You got to remember, I'm not perfect, so everything I build has its flaws for sure. But let's see here. We are right just under 4 inches, about 3 3/4 inches of ground clearance underneath the box there. And so that is a concern. Now, I can trim the differential housing boxes off here and gain 3/4 of an inch of ground clearance and have a maximum of 4.5 inches. And that would not limit the integrity of these boxes at all. They're so overkill. That would just, I would trim it and then weld a flat plate there to eliminate this corner. That would give me 3/4 of an inch more ground clearance. But if you look, there really is pretty good ground clearance. I know in the videos I'm in grass that's really long, and so it looks like those boxes are about to to hit the ground, but they're really not. There's pretty decent ground clearance there. So let's see, what other questions were asked? The cost of the board. A number of people had asked what I've got invested in it. I probably have, I don't know, somewhere in the range of $2,000 or so spent. Well, maybe more than that. I don't know. It's hard to say. A lot of the stuff that I built the board out of I had laying around. But if I had to start from scratch, it would probably cost me $3,000, give or take, to build the board, plus maybe 200 hours of time. Is it overly complicated? Probably. Definitely not something, though, that I was, looking to build multiple boards or to market them at all. This board, oh, also, the biggest question, why such a big board? And let's see, just get some good images of it there. I've got my camera set on wide angle, so there's a little bit of fisheye effect, but why such a big board? Well, actually the whole project, as I mentioned in the beginning of the video, started by me looking for something that I could ride in the snow. So upon looking, I realized obviously snow tracks would work best. They are crazy expensive, very complex to use. They are extremely inefficient, would use a lot of power to move slowly with tracks, and it really limits its use to the winter almost exclusively. So I decided ATV tires. Then when I decided on this size tire, the size of the tires definitely dictated to a large extent the size of the board. I stood on the ground and I put my feet a certain distance apart, and I measured that distance, so I knew the deck had to be a certain width in order to accommodate the stance I wanted. And then the size of the tires to a certain extent dictated how much steering I could get out of it. So I needed a certain amount of room to mount the drive unit. Since the steering pivot's in the middle, the drive unit had to be offset. So a certain amount of clearance was needed between the steering pivot and the wheel for the drive unit. So that dictated the axle width. Once I knew the length of the deck and the axle width and the tire diameter, then at full steering lock, I needed to make sure that the deck would clear the wheel at full steering lock. So you calculate all those things together. Again, length of the deck based on my stance, diameter of the wheels, wheel steering clearance, axle length based on clearance for the drive units that I already had in stock. All of those things combined required or dictated that the board be this size. Now, the board could have been smaller if the deck were mounted very high above the wheels, but I didn't want something 2 feet off the ground. I wanted it as it is. It's nearly a foot off the ground, so I didn't want the board to be too tall. And actually, when I first started building it, I thought, this is ridiculous. It's going to be way too big. But again, the size of the tires, it just everything. One thing dictated a certain size of another thing, and that was a design constraint that dictated the size of something else, and it just snowballed into what we see here. I did not draw this before I built it. I just started building and let the design evolve as it would. There were certain things that I had to think about ahead of time, obviously, but the weight of the board, I made everything as light as I possibly could. I used as much aluminum as I possibly could. The suspension arms here and this steering, what I call the steering carriage, let's see, come around here, this steering carriage are steel primarily because to make them out of aluminum would have required much larger material, and I didn't know if I had clearance. So these parts are under a lot of twisting load, and so steel was best. Admittedly, they are pretty heavy, being that they are steel parts, 16th inch wall, hollow steel tubing. I may start experimenting remaking them out of aluminum just for grins, but for now those parts are steel. I used as much aluminum as I could. This decking material is G10. It's sometimes called Garolite. It's 1/8 inch thick, a little bit similar to carbon fiber, but a lot cheaper, not quite as strong, not quite as light, but it's still light and strong, inexpensive material to use. So I tried to keep it as light as possible, but weight becomes just dictated by size and battery capacity and that kind of thing. So let me think here. Complexity. The board is as complex as it had to be just for its intended purpose. As I mentioned in the previous video, everything is adjustable. The steering kingpin angle is adjustable. The ride height is adjustable via this adjustable turnbuckle. The steering dampeners are adjustable. The steering centering springs are adjustable. I mean, everything. There's Heim joints everywhere. Adjustability was of a prime concern. The board is as complex as it needed to be to function as I wanted it to function. Could it be made simpler? Maybe. You could eliminate the suspension. Now that I know what angles work well, I could build it non-adjustable with no suspension, fixed steering angles front and rear, and it would be far quicker to build. But for full suspension with a lot of adjustability, this is really about as simple as a four-wheel drive board could be built. Maybe a single stage reduction instead of the two-stage, but two-stage allows higher RPM for more torque at the wheels with a smaller motor. And again, I go back to, I had these drive unit components in stock already. So yeah, I think that answers the bulk of the questions. Also, a few more details. These are machined aluminum go-kart hubs. The axle is 1-inch diameter. I had to drill these ATV wheels to that bolt pattern, but that was a piece of cake. So, oh, the steering pivots. One person had mentioned that it looks like the steering would bind up really bad on this thing, and it could. It definitely could. The steering is on ball bearings, and there's actually 2 ball bearings at the top and then 2 ball bearings at the bottom. So there's actually 4 ball bearings at the pivots. And those bearings have a 1/2-inch bore. Though the axle is aluminum, there is a steel sleeve, a stainless steel sleeve pressed through and then held on with 4 set screws into this aluminum, and that sleeve is what the bearings ride on, and then they're captured with the through bolt. So the steering load is handled by 4 bearings front, 4 in the rear. Those ball bearings allow for very fluid and smooth steering. Now, a couple people had asked if the steering feels heavy on such a large, heavy board with such large tires. Honestly, no. That may seem strange, but the steering is light. In fact, almost too light. It really steers easy, to the point where the steering dampeners actually become a little bit critical, because without them, the steering is so hyper light that it's, I mean, the tiniest lean and it's steering really sharp. Oh, a few people had asked if it will carve or if it just lumbers around. It carves wonderfully, far better than I thought. So again, for a big heavy board, it does steer very light. One thing I have to say also, I built in some extra wheel clearance because I want to put snow paddle tires, normal 20-inch ATV, very wide snow paddle snow tires on it. I would reduce the gear ratio down a little bit, put the big paddle tires on it, and try it in the powder snow and see how it does. So anyway, it's got monstrous power. If I lean forward on the board and gun it hard, it will spin all 4 tires with me on it. Even on the pavement, in the grass, in the dirt, it just spins all 4 tires under acceleration. It will power slide. It's a lot of fun. So anyway, super long video, and I know, but I just wanted to give you guys some information on the board, answer some questions that were asked. I know this is a long video, but for those of you that were curious, now you know. So I'm going to go ahead and show you. Here's one of my personal bikes that I built from scratch. You can see that my drive unit that I manufacture there. This is a mountain cycle San Andreas that I cut and made my own frame. It was damaged already, so it was a basket case, so I repurposed it into an electric bike. This bike back here has 2 Astroflight 3220 motors on it, and about 50, oh gosh, probably more than at probably 60 pounds of lithium in this box. This bike is 32 horsepower, 125 pounds, goes 45 miles an hour, and is almost a motocross bike, really. So I've got hanging on the wall there several other bikes, so a lot of fun. Maybe one day I'll show you guys a video of my workshop and you can get an idea of the equipment that I use. But anyway, I think that's plenty of length for you guys. So go ahead and like and subscribe. If you have any questions, let me know. I'll do my best to answer whatever I can. Take it easy, guys. Bye-bye.